examples. Determining if um, these values are making that inequality true or false. Did you select those to the ones that are true? Yes or no? So with this particular inequality here, w plus 2, what's that symbol again read as? You gotta know it like that. That's my greater than symbol. W plus 2 greater than 4. So plug it in, and is that a true or false statement? That truth value, yeah, is that true or false? And on that first one, as you're seeing, you're checking 0. Then you're checking is a -6 happening, is a 2 happening. Those are what all you're doing that start off with here today. So those should be just a quick, rapid response off of that. So I'm going to put just being true then. Essentially all we're looking for is that left-hand side all has to be greater than 4, right? So the first 3 were not greater than 4 after we did a little algebra, a little bit of arithmetic. And as Andrew and Ryan said, this one was close, but in order for this one to turn true, we need to have the equal to underneath of that. But unfortunately, it doesn't have it there. So that's why, again, we have false, false, true. Now, yesterday we in our delta math, that's essentially what we had right there. And same thing like on number 2. Which of these are turning out to be true? Circling or put in X, checking all that are true here. Now here, we just gave you the inequality. You plugged it in. Did you get a true or false statement? Here, we're looking at the graph, right? And which ones are falling in the shaded zone. So as you can look on yours, you probably can definitely tell a little bit darker going to the left. And also looking very closely, is that open or closed?
Open.
Open means, are you a solution or not?
No.
No. Open means we are not at 4. We're like right up on it, but we are not able to stand on 4.
So it's like 3.9.
So like, yeah, 3.9, 3.9999999. We're almost at 4, just not quite.
Less than 4?
Correct. So what this is saying here is, as Ryan then just said, the inequality that goes with this is just less than 4. It's not got an equal to it, and the reason why it doesn't have an equal to it, it's not closed. So of these options here, which ones are we selecting?
3.75 and negative.
Well, for sure, anything that's got a negative, right? Because less than 4, those are all negatives. And the only negative I see here is.
Are we checking a 0?
And we're going to check the 0 for sure.
3.75.
0 is definitely less than 4. We can clearly see it's in the shaded zone. Now, this is the one that we always got to pay attention on, if it's closed or not.
When it's open, when it's closed, then it'll be
Correct. So on 4, it's open.
So it's 3.75.
Right. Open means we are not able to stand on 4. Open means it is not a solution. 4 is not. 3.75 is. It's right about here. It's in the shaded zone. It's less than 4. And then 4.01, you got to remember it's on the right-hand side. It's over here, and it's not a solution. It's greater than 4. So checking all those out, that's the best that we can say. Knowing what does it mean to be a solution. Is it less than, greater than? Is it in the shaded zone? Is not in the shaded zone. Which is the same thing as number 3 is. The only difference is they give you the inequality, they don't give you the graph. This is what we just did up here. What's the truth value? So if you like the graph, fine. We can make the graph very easily. Make -7.5.
So it is closed.
It is closed. So we're going to make a quick graph here. It's all going to happen at -7.5. And as Andrew pointed out, the reason why it's going to be closed, it's that equal to. I always circle it. The follow-up question we always ask ourselves is, do I close it? And we do, because it is got a or equal to underneath of that.
Well, you can just remember you.
Wait, so why are you closing it?
Because there's an
Because
equal
that's
to
a line
there.
A line under like a less or greater, that's an equal to.
And then we went greater than 7.5. We went numbers greater than negative 7.5. Greater than negative 7.5 goes to the right. Now, as we look here, you got to know where you're in relation to negative 7.5. Negative 42, where is it on there?
It's on the left side.
Way below. Yeah, bless you. It's not less than, so that's not it. Positive.
Yes.
Yeah, positive 7.5 is larger.
Yes.
We're right on it. And because we're right on it, we closed it. Closing it means we can step on negative 7.5. When it was open, I can't step on it. Right. Negative 7.6.
No.
It's on the left of it. Negative 7.6 is less than. Negative 7.4,
Yes. Greater.
yes, it's greater than. It's on the right of it. And those are my, three that we're checking. These are not anything crazy special or anything like that. But as we move into our next two lessons here and wrap things up with, you got to know your basics of the number line. Which takes me to knowing your vocabulary and making those number lines. So let's take number 4. Make me the inequality that goes with the description, goes with the words of that. So we are already given the words, is less than or equal to 42. So the words was given to us already. Make me the inequality symbol that goes with x is less than or equal to 42. If you can't do that for us, what have you been doing for the last 5, 6, 7, 8 years? Okay? So, less than or equal to 42. Less than or equal to 42. Okay? So, we always usually put the variable on the left. X is less than or equal to 42. Now, put it on a number line for me. There's a blank number line. Graph it for me. X is less than 42. Put 42 someplace on there. I don't care. It doesn't have to be exact. All right? And then on that 42, we always circle the number, 42 in this case. But you got to ask yourself one more time, are you going to close it or leave it open? And the reason why we're closing it is because that equal to part. The equal to, the underline, that closes it. So close it. Make it solid. We're making it solid. That means 42 is part of the solution. And then which way do you shade? To the left, to the right?
Left.
Less than. We want numbers less than 42. So when you shade this now, make sure you're shading it carefully. That Ms. Keno and I can tell, oh, you're shading it to the left. I know some of you shade directly on that line. It's hard to tell. So make sure you clearly are shading it to the less of 42. So we want numbers less than 42 and
Equal to.
42 is also fine as well. Correct. Jalen. I'm sorry? Yep, give us a second to put you in line. Now, on the next one, I give it to you in a different viewpoint. I don't give it to you in words. I give it to you written as an inequality. However, is x by itself? X has to be by itself. So what we're going to do here is, yes, we are going to do some math. Let's drag it down here into this blank spot where we got some room. Give you a sec. And this brings in our solving skills. Before we go and graph this out, we got to have x by itself. You got to solve for x, just like we've done everything. So before we can put it in words, write it as an equality, put it in a graph, let's solve for x. So who cares if it's an equality? Who cares if it's a equal sign? Doesn't matter. We go about using our solving skills.
So it's like what we were doing.
Absolutely. X is on the right hand side. How are you going to get x by itself? How are you going to move that 7? Right. Ask yourself the same inverse operations we've been doing for the last couple weeks. Right. I heard subtract 7.
So negative 17 equals x.
And
Not
then
equal. is.
I got you. I got you there, Andrew. Sorry, Kendall. And as you do that, I said you don't need your calculators earlier, but this is a spot where we would check it with our calculators, negative 17, and the inequality symbol just drops on down, and there is our x. Okay, x is now by itself. Now, how do we read that? Negative 17. Now, how do we read that symbol?
Less than X.
It is my less than symbol. Is less than x. You can say less than a number, but go easy. Is less than x. That's all we're looking for when we say in words. Biggest thing Miss Kendall and I are looking for is, do you know your inequality symbols? Less than symbol, greater than symbol, or equal to. Now we got the inequality. We just solved for x. Cool. So now we can drag that up the top there. But I couldn't drag that up top there until x was by itself. I can't make the graph until x was by itself. So put negative 17 somewhere on there. I don't care where you put it. And then we always ask ourselves, do I close that circle? Do I close that circle? No. And that should be immediate. If you're sitting there going, I don't know if it's open or closed, raise your hand. Ms. Keel and I will come around and clarify that for you. But again, the reason why we're not closing it, it doesn't have an equal to underneath of that. That means it's open. That means negative 17 is not going to be a solution. Now, don't shut out the answer here of which way we shade. We can tell on this one versus the other one, the x is on the other side, right? X is on the right-hand side, x is on the left-hand side. This is where your years and years of inexperience, I guess, with inequalities catches up with some of you. Negative 17 is less than x.
So going left.
And that's where,
We're going to the
yeah,
right.
we're going to be going the other direction. So my suggestion here is, let's throw out a number that is clearly on the left-hand side. What's a number clearly on the left-hand side? Negative 50. Is it negative 50 over here?
Mhm.
Plug it into the inequality and ask yourself, is it true or false? If I plug in negative 50, is this a true statement?
True.
Negative 17 is less than negative 50.
No.
Yes, since it's close to 0, right?
No.
Negative 17
is greater.
greater than. Negative 17 is greater than. That is a
I know the exact
false statement. Where should I
negative
go?
17 is less than 17.
So what that means is I should be going
To the right.
to the right. I'm going to take Matt's suggestion of a 17. 17 is on the other side. If I take negative 17, and he said is less than 17, that's a true statement. The part that confuses a lot of people is this x on the right-hand side. You can't follow the direction of the arrow, which most of you have just grown up with, and your teachers say, shade the direction of the arrow. That's only true if the variable is on the left. When the variable is on the right, it goes out the window. Okay? So this is where I like to plug in a number. That's why we start off today with true or false. Okay? This is a false statement. True statements get the shade. So take a number, plug it in, and ask yourself, is it true or false? You know true statements get the shade, false statements don't. True statements are the solutions. It's that dang variable on the right-hand side that screws you guys up because you don't have a solid foundation come up to me all the time. Okay? All right, let's do another one. Let's flip it. Let's look at the back side. Okay, the last one here, what are we given? We're given the graph. Let's make the inequality and put it in words. Where's our graph starting off at? Starting off at negative 2, I heard. So x and negative 2. And what's the comparison we got there? Thank you. We can see it's going less than, and it's going to be the equal to. Equal to because the dot is closed. And as I think Chris Meyer said that, maybe not. Less than or equal to, what is it? -2. That's all we mean by in words. Okay? If you can do these three things all together, you're looking great. Okay? Now, small application of our inequality symbols. A bus can seat at most 48 students. What type of inequality does this look like? A bus can seat at most 48. So, a bus can seat at most 48 students. What does this look like? So, we get a variable in 48. Okay? What's that going to look like? So, on here, all right, we're going to be at 48 on our number line. Where's 48 on our number line? I'm always going to circle it. Can we be exactly 48? When they say it can be at most 48 students, can we have exactly 48 students on there? When they say the word at most.
Yes.
At most means inclusive. At most means we can, so we're going to close it. And now, the word at most, which way do we shade that? Krista, you just said it there. Which way are we going to shade that, Krista?
Oh, it's less than or equal to.
Right. Which way
Oh,
will
I
we?
mean the left side.
Which way we shade that? We're not going to shade it going to the right because the right would take me to 49, 50, 60 students. I can't be at most 48 and say 60 students is appropriate. So I'm shading to the left. And as I'm shading that to the left, what this is code for is, as Krista rattled off, this is less than or equal to. X is less than or equal to 48. So that's what that means. 2 kids on there, fine. 3 kids on there, 13 kids, 20 kids, 21 kids, 40 kids, 48 kids, those are all fine. But 50 kids is not, okay? Now, when we said less than or equal to, where does that continue on? That continues on to 1, 0, -5, -100, -1,000, and so on. On this last question I have for you, -25 says that's cool. But why does that not make sense to this particular situation? Right. Can we have this idea of -25 students? No. So you cannot have negative, let me write that out. You cannot have negative students. So in math, you get funky things sometimes. That's a funky thing, okay? So in math, sometimes you can get a negative answer as we got here. But you got to think, because this is a word problem. Does it make sense in the context of this problem to have a -25 students? No, it does not. Okay? So we're going to toss that out. Where do you think this actually would stop at? What would be the lowest number you think would be appropriate? I'm sorry? What would be the lowest amount of students that would be appropriate?
One.
Or 0, right? 0 would be the most appropriate place actually to stop or start that inequality at. Because when the driver starts the bus route, how many students are on the bus route? Start.
2.
They pull out of the garage, they're at 0. Okay, last one here, I think. This is one everybody should be familiar with. You must be at least 16 years old to obtain a driver's license. Okay, 16. 16 is it. Now every year I go through this problem.
So it's X greater than 16?
So 16 is where we're at. We're going to close,
Since-
open or close it.
It's gonna be open. Wait, closed since at
Because
least.
at 16, can you actually get your driver's license at 16?
Yes, if
You
you have
can.
enough time.
If you've got your hours and classes and all that, right?
And you have your permit.
Obviously. So if you get all that checked, cool. You can get it at 16. Now, which way are we going to shade that? To the left. No.
Yeah. No.
14-year-old, 12-year-old, 10-year-old? No. What's appropriate to drive with a license? Going to the right. Now, what is the inequality associated with that?
Greater to equal than.
Correct.
Greater.
So we got to be greater than or equal. X is greater than or equal to 16. That is appropriate to get a driver's license after you met the criteria, right? Now, every year I go through that one, and I'll usually throw this one on a quiz too. Slight variation on that, but based off of how some of you answer. Some of you should probably have a driver's license maybe right now, and then when you turn 16, you give it up. Because based off the results I see, a lot of you have flipped that inequality sign around and say, hey, at 6 months of age, I get a driver's license. At 2 years of age, I can be driving. Because you all are putting less than symbols out there, which is ridiculous.
You also need to look at the dragon law.
Now the last thing here it says, same deal, greater than or equal to 16. 200 is a solution to inequality, but why is it probably not considered appropriate for this solution?
Because no one's living that long.
Probably no one's living to be 200 years of age right now, right? So that's why. I'd like to live to be 200 years of age. But here, people do not live to be 200 years, right? At least not right now yet. Okay, and you're driving. What's that?
Soon, maybe.
We'll get there eventually. Not right now. Okay, so with that, right there, that's what we're going to be working on with inequalities coming up and throwing our solving skills out there. So for the rest of this period here today, we're going to do one of two things: finish up the quiz, start the quiz, and the rest of you, I've got an assignment here that goes with it.
This kiddo.